Sorry. Hello everyone, we're group number 5, and our project is automated solid waste separation system. Our group members are Hanser, Castro, Bravo, and myself, Alfredo. Our project is sponsored by Sabri Tosunoglu, which is present today, and our project advisor is Dr. Sabri Tosunoglu. Although recycling laws have been passed to many countries, especially on the developments, large amounts of solid waste materials have not been recycled properly. Therefore, there's increased of usage of incinerators and garbage in landfills. Some problems that are caused by the usage of incinerators and garbage in landfills are air pollution and soil contamination. As you can see in these pictures, these are a few examples of bad waste management which cause social and environmental issues. Globally, we designed a system to ensure proper management of solid waste materials, also to reduce environmental contamination and create new jobs, therefore improving the living condition of our society. The core objectives as engineers is to design, simulate, and test a prototype capable of recycling solid waste materials by the chemical composition by using the triboelectric effect.
Now, these are some of the standards that we're going to use on this project. The purpose for these standards is to ensure the safe operation of the system and also ensure proper management, separation, and sorting of solid waste materials. Now, to separate the materials, we will use triboelectricity. Triboelectricity is a static electricity generated by friction. It occurs when a material becomes electrically charged after it comes into frictional contact with a different material. When we apply friction between two objects, we can exchange the electrons between them. Some materials have a tendency to give up electrons and become positive charged. Others have a tendency to gain electrons and become negative charged. This is described on the triboelectric series you can see here. This is a useful tool to determine the combination of materials that create the most static electricity. Now, it is important to find the force between the materials to be separated. To do this, we have to look at the Coulomb's law. Coulomb states that the electrostatic force is equal to the scalar multiplication of the electric charges divided by the square distance between them. From that formula, it's important to know that like charges, such as positive to positive or negative to negative, will create a repulsive electrostatic force. Unlike charges, such as positive to negative, will create an attractive electrostatic force. Now, the triple cycle and the rotating tube turbochargers are two of the triboelectric separation methods that already exist in the industry. Due to friction and the constant contact between the particles, the material becomes turbocharged. After all, particles are led to fall free on a tunnel, and particles with positive charge, they will be attracted to the negative electron. Particles with negative charge, they will be attracted to the positive electron. Now, the main difference between these two systems and the one we're presenting and designing is that this can only be used to separate materials based on the electrical charge, while our system will separate materials based on the chemical composition of the material. Now, this table here shows the four main components that we want to separate on our system. Let's say, for example, that we're focused on glass. If we want to separate glass, glass has to be rubbed against silk. Glass have a tendency to give up electrons to silk, leaving the glass positive charge. On the other hand, we need an attractive material to collect that glass. This material will be PVC. If we rub PVC against leather, PVC have a tendency to gain electrons from the leather and become negative charge. So at this stage, we have glass with a positive charge and PVC with a negative charge. Since these two materials are part on the triboelectric series, we will have a very good attraction between them.
In order to design our system, we have to follow certain constraints. One of them was to have 20% humidity in our system in order to create a dry environment so the chargers last longer. We also had to work with the space constraints because we didn't want to make a machine that was too big. Specific materials also have to be used in order to provide optimal frictional force, and all the materials that are going to be introduced into the system have to be crushed to sizes between 50 millimeters to 30 millimeters. Our system is going to be composed of three major components. The first one is going to be the one that's going to provide frictional force. The second one is going to connect the materials, and the last one is the structural design. Initially, from our first design alternative to provide frictional force, we wanted to use a endless screw design. We didn't end up using it because of its irregular shape, didn't provide optimal frictional force. Also, after the material went through the system, it had to be sprayed out, and this is time consuming. Further research led us to use the magnetic roller. In this case, the roller is going to be attached to the body arm, and the roller in the front is going to be covered by the specific material that's going to provide friction and force. One of the advantages of this system is that it's capable of providing optimal frictional force. Also, it's easy to repair and provide maintenance, and therefore is cost efficient. Our second component in our system is going to be the magnet to collect the material. Initially, we wanted to use the concept of the hydraulic magnet. We didn't end up using it, especially because of control issues, since we didn't want to create a machine that was too big and we wouldn't control it 100%. So we disregard this idea, also because of the charging efficiency, since for our specific design, the magnet needs to be able to be charged. This system cannot do that unless we make modifications, and that's time consuming and it's not cost efficient. So we ended up with a magnetic arm. In this case, the magnet is going to be attached to the magnetic arm, and it's going to be connected to 2 frictional rollers on each side that are going to charge the magnet. Also, one of the advantages of this system is capable of being charged, as you can see in the picture, and collect materials at a very high rate, therefore resulting in consistent product quality and higher production rates. And finally, this configuration is capable of also being insulated, which stops charges from being discharged to other components or employees working nearby. And finally, the last component in our system is going to be the structural design. Initially, we wanted to use a structural design, but this was disregarded because it was too complex, especially when we wanted here to provide maintenance, and so it was going to be too expensive. So we decided to come out with something else. And that's when we came out with the U-shaped design, especially for safety reasons. Also, accessibility. Due to its shape, it's very easy to have access to the system, and in case that something needs to be repaired, replaced, or something's blocked in the system, it's very easy to take it out and without affecting the operation of the system. Finally, these are the components of our system put together in our final design. Initially, all the components are going to be crushed to size between 15 millimeters to 30 millimeters, and going to introduce through the funnel, and they're going to fall into the glitter belt. The glitter belt was chosen because it wasn't ideal for this design in order to keep their materials, the recycled materials, organized while they get frictional force. Once they fall into the glitter belt, then we have the frictional roller, which is going to electrically charge the materials, and then the magnet is going to collect them. Once the materials are collected, then the system is going to connect to ground. It's going to release the materials and specifically where they belong. We're going to have 4 different stations, which are going to collect glass, paper, non-ferrous metals, and glass. We only show the 2 here for simplicity. Once at the end of the system, all the materials that weren't collected are going to be disposed of, that are not within these 4 materials.
In this chart, we have divided responsibilities and tasks throughout the 2 entire semesters, starting from the early stages such as project formulation until the final design. The next steps for our project is to continue the development and optimization of our design, also to analyze the ideal time for the materials to be charged, also the charge for each materials and the frictional force through simulations and experiments by using the university's facilities. And lastly, we're going to build a prototype to be able to ensure that the concept works and its efficiency. Thank you, and we'll go for any questions. Thank you.
Yes, go ahead. Yes. So the design does include this part, both systems are inclusive of this project, right? The crushing or the sizing of the proper bulk material and the separation, right? Or just you're concentrating on the separation portion?
Just the separation.
Just the separation.
Yeah, just the recycling of those 4 different materials.
Okay.
That's what we're concentrating on.
The other kind of project, the other system is going to be drying the material and crushing the material between 15 millimeters and 30 millimeters. Once the material is dry and is ready being crushed, then it comes here and through the separation process.
As far as the constraint that you have, you're planning for any variable constraints, such as you said that you have environmental issues, for example, you're drying so that you can have your proper separation of materials according to charge and so forth. What considerations are you taking into account for any changes in environment? Too much humidity or too much heat or too cold?
Well, all this process has to be with a relative humidity in the environment between 20%. To do that, we have to enclose all this system using a dehumidifier to reduce the humidity that already exists on the environment. Of course, between 20% to create, at that humidity we will have a very good attraction to create the static electricity.
I asked that because when I see the conveyor itself, it seems open, right?
Yeah, it seems open, but for simplicity,
Okay.
we show all the components so you can really see how the system is going to work, all the components that it has. But that's the idea.
The idea is to improve current recycling efficiency, which is there's roughly 47%. We want to increase it up to 99% using the system. So that's going to have big impact in the environment. As more technology like these are being developed, and we take it to the market, it's definitely going to make impact, not only in this country, but in all around the world.
So this system is going to use clean technology. We're not going to use any chemical. It's just using the chemical composition of the material, creating friction in order to be separated.
One last remark, and you're talking about how efficient the system is and so forth. And the question leads up into at the end, right? So you have your control environment, you have to expend some energy into doing so, right? Things to consider would be how efficient would this be and how much energy you're going to input into the environment itself to create the perfect conditions so that this machine works as designed. So those are things that you have to consider when you're accounting for uncontrolled variables or the environment itself, right? You have too much temperature, it's a rainstorm here. If it's South Florida, you know that 5 minutes it's 100% humidity, 5 minutes later it's about 70. So it could change, so forth. So those are things to consider when you're going into the constraint bearing and the accounting of how efficient would the system be, and have that conservative or a little bit outward of the box increase in performance that you want to achieve. Okay?
All of those constraints we're going to really take into account once we build the actual prototype. We're going to start building, as Alfredo mentioned, the prototype probably in the summer, because this is a project that it hasn't been done. We're basically designing and creating something. Yes, something is already there in the market, very similar, but not separation by the chemical composition of the material. So we have to take into account seriously all the constraints, everything on our system in order to be efficient and to be able to separate all the materials that we want.
This was by far one of the hardest things we ever worked on. We spent roughly a month trying to put all the ideas together, think about safety, all the things that was going to work. And that took a lot of engineering thinking and logical thinking, but at the end we were able to put the system together. And when we're going to be able to build it, we think we're going to have excellent results. We're going to have to wait for the test.
What about cost? What about the cost aspect of it? If you,
We have budget of $2,000.
how much?
We have budget of $2,000 to build the prototype.
So then
We have a budget of $2,000, but we want to stay under that budget if possible, just to build a prototype to separate one specific material. Of course, due to budget problems and time constraints, we won't be able to build the whole thing because a system like that, with counting of the material, the design, we're talking about roughly $200,000. So for our single design, we want to build it, we want to prove the theory works, and we want to prove the efficiency for one material due to the constraints.
So then what scale, considering all these constraints, what scale are you looking at building this at? Are you looking at building this full scale? Or are we talking about a commercial separation unit, or are we talking about a small scale?
Small scale, between 5 to 6 feet, just to build the prototype to make sure that the concept and the theoretical part works. So it's basically just small prototype. It will be made out probably of aluminum because it's cheap. It's not a heavy metal. So that's the goal.
Our goal is to eventually make it to the market, actually build it and make it a change in the environment.
Once we build the prototype and make sure that the first station to separate the material works, then we have to adjust the materials and we can build basically the full-scale project.
Can I take a look at your timeline, please? Can you go back? So right now, you should have finished your simulations, or at the end of April, or you're starting your simulations.
We're starting the simulations.
Okay. You have, since this is a very complicated system, you need to make sure you time everything effectively. Don't fall behind.
Yeah, sure. This is a very complex project, as you said, so we don't want to stay behind our schedule.
It was a lot of work and dedication not to get to this point, because it's a lot of components that you have to put together, and you have to think about all the safety issues, engineering, that it's going to work, it's going to be efficient, it's going to be able to maneuver, so it's a lot of work.
Any other questions?
Let him go.
Yes.
Thank you very much.